All right, so in this lecture, we are going to look at the CHS Mathematics CA questions, and I'm going to be providing solution to the 20 question at a stretch. So this is going to be a very long video. Please endeavor to follow the process, learn every step that is there. Don't just copy. You know my policy. Don't just copy. Learn everything that is there because this question might likely be repeated for you in your exams. So if you just copy, at the end of the day, you meet questions like this in your exam, you won't be able to do very well. All right, so we have the first question, although I didn't really type the first one out because I thought the question was incorrect, but we'll solve it the way it is. The question says you have log to the base of 2 the let's leave that first question. The same thing incorrect. It was not properly written, it was not clear. Let me look at the second one briefly. Now the next question here says evaluate the inequality. Now the inequality you're given, my dear student, is x squared plus 2x is greater than or equals to 15. Now if you have something like this, to evaluate this, you have to make this to be greater than or equal to 0. So this will give us x squared plus 2x is, if this minus 15 crosses to this other side, becomes minus 15 is greater than or equals to 0. Now we are going to simplify this expression we have here, factorize rather. If we factorize this expression, what are we going to add that will give us 2x? And when we multiply it, it's going to give us minus 15x squared. Because the general idea is that you use this x squared to multiply 15, so that will give us minus 15x squared. So we are now going to look for two numbers in such a way that when we add them, they will give us 2x, and when we multiply them, they will give us minus 15x squared. Of course, that number is 5x and 3x. Now, in what way are you going to multiply 5x and 3x that it will give us minus 15? Either the negative sign is on 5 or a negative sign is on 3x. Because if a negative sign is in one of them, when you multiply them, it will give us this minus 15x squared. But we still ought to put these 2x into consideration in such a way that when we add both of them, it will give us positive 2x. So in that way, the negative 3 is the one that will carry, the 3 is the one that will carry the negative sign. So that 5x times minus 3x will give us minus 15x squared. 5x minus 3x will give us 2x. Is that okay? So we put that into this equation. This will give us x squared plus, wherever you see this 2x, put 5x minus 3x minus 15 is greater than or equal to 0. What is common between x squared and x? Of course, x is common. So we have x plus 5, because if x divide x squared, give us x. 5x is divided by x, is going to give us 5. What is common between minus 3x and minus 15? Of course, minus 3 is common. Now, 3x minus 3x divided by minus 3. Negative cancel negative, give us positive. 3 cancel 3, it will give us 1 times x, that will give us x. Negative going to negative, that will give us positive. 15 divided by 3, that will give us 5. This is greater than or equal to 0. By basic laws in mathematics, which you are taught, if you have something like this, you collect one of them in this bracket. So this gives us x plus 5, and then you collect this one outside, which gives us x minus 3, greater than or equal to 0. Now, at this point in time, we need to find the critical point. The critical point, so you write, find the critical point. The critical point is the point where these signs will change if you plot this in a graph. All right? Now, the critical point, you calculate it by setting each of what is in the brackets to be equal to 0. So this gives us x plus 5 will be equal to 0, and x minus 3 will be equal to 0. Is that okay? So let us now find the value for x. X plus 5 is equals to 0. If you find x, this plus 5, positive 5, crosses to this side, my dear student, x will be equals to minus 5. And if this other x crosses to this side, x will be equals to 3. Is that okay? Now, these two values will split the number line into 3. Now, what number line are we talking about? If I draw a number line like this is not neat. Let me stop presenting. Okay, I've not even started presenting in the first place. So let me just come here and draw. I think this is good. Now let's draw a number line. If this is a number line, my dear student, this point here is our 0 mark. This point here is minus 5. And this point here is 3. These are the values that you have. Now, there are 3 parts of this number line. You have a part where x is less than 5, minus 5. That means this part. Are you getting it? X is less than minus 5. This part here. If x is less than minus 5, my dear student, this is this part of the number line. So you have x less than minus 5. Then you have another one where x is greater than 3. Is that okay? So we have x is greater than 3. I will have another one in the interval between minus 5 and 3. Is that okay? So that one will be minus 5 less than x, and x is less than 3. This is this interval here, the open interval. So we are now going to consider these ones here and see which of these ones actually fit into this equation. Now, how do we do that? We are going to plot in each of these values into this equation and see the one that will be greater than or equal to 0. So we said we have 3. One is x less than minus 5. One is x greater than 3. And the other one is what? Minus 5 less than x less than 3. So that's what you are going to write. Right? I'm going to teach you inequality from the scratch. All right, so these are the critical points we said. Now, one thing you need to do, my dear student, is this. One thing you need to understand is, at this point you have, from what we saw there, we say we have x is equals to minus 5 and x is equals to 3. We plotted this on the number line. This is minus 5, this is 3. Now, we can have values less than 5. We can have value between minus 5 and 3. And we can have values greater than 3. Are you getting it now? Now, what we are now going to do is to put all this into the equation. Any one that is satisfied, if this one is satisfied, that means if you put any value less than minus 5 into this equation you have here, if your answer is equal to 0 or greater than 0, then that one is a solution. If you put x greater than 3, any value greater than 3 into this equation, and your answer gives you greater than or equal to 0, then that one is a solution. If you put any value within this limit into this equation, and your answer gives you either greater than or equal to 0, then that one is a solution. What do we mean by that? Let's put the first one, x less than minus 5. Now, what is that value that is less than minus 5? Of course, the value will be like x is equals to minus 6, because minus 6 is less than minus 5. So put x is equals to minus 6 into this equation and see if it will give you any number greater than or equal to 0. So this will give us, put it into this equation. The equation is s plus 5, or s equation, yeah, s minus 3 greater than or equal to 0. Put it here. Here will be what? Minus 6 plus 5. Wherever you see exponent minus 6, and then here will be what? Minus 6 minus 3 greater than or equal to 0. Now, minus 6 plus 1 will give us what? Minus 1. Multiplied by minus 6 minus 3 will give us what? This will give us times minus 6 minus 3 is what? Minus 9. Should be greater than or equal to 0. Minus 1 times minus 9. That will give us what? Negative 1 multiplied by negative 9. That will give us what by just then? That will give us 9. So, and 9 is greater than or equal to 0. That means this value here is a solution of the inequality. Is that okay? Now, let us try x is greater than 3. Who is there? To do what? Which bottle is that? No, 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 no. At 13.21. Okay. Where is that? So it means that this first inequality here is satisfied. Now let us put a value s is greater than 3 into the equation and see if it will give us a value greater than 0. Put s, any value s greater than 3. Now, s greater than 3 can be a value like x equals to 4 because 4 is greater than 3. Put it into this equation and see. That will now give us 4 plus 5 into this equation, 4 plus 5, bracket what, my dear student? 4 minus 3. Because 4 plus 5 will give us what? 4 plus 5 will give us 9. Is that okay? Then 4 minus 3, my dear student, will give us what? Will give us 1. Greater than or equal to 0. Of course, 9 times 1, this will give us what? 9 is greater than or equal to 0. So this one is also satisfied. Is that okay? It could give you anything, but this is what this particular one gave to us. This one is also very, very satisfied. Now, let's see any value minus 5 is less than x and s is greater than 3. So it means this is a solution, this is a solution. Now, let's look at the last one. Minus 5 is less than x and x is less than 3. What do you think that values are? Minus 5 is less than x. It means x is greater than minus 5 and s is less than 3. If x is less than 3, that value can be 1 because 1 is less than 3. That value can be 2. It can even be 0. It can be minus 4. So I'm going to choose 1. Let's use 1 and see. Put 1 into the expression. What was the expression? Don't cancel them. The expression was, I think, x plus 5 bracket x minus 3 greater than or equal to 0. Like I said, minus 5 is less than x and s is less than 3. Anything less than 3 can be 1, can be 2. So let us put 1 into this equation and see if it will give us a value greater than or equal to 0. So we put 1 here. Here becomes 1 plus 5 bracket what? 1 minus 3 greater than or. Now, 1 plus 5 will give us how many? 6. 1 minus 2 will give us what? 1 minus 3 will give us 1 minus 2 greater than or equal to what? 0. Now, at the end of the day, when you simplify this, this is minus 12. Minus 12 is not greater than or equal to 0. Are you getting it? It is less than. So this is not satisfied. So the correct answer to this question is x is less than or equal to minus 5 and x is greater than or equal to 3. So the correct answer to this question is what? X less than or equals to minus 5 and x is greater than or equal to 3. You can write this in set form and say x is an element of minus infinity to 5 with 5 inclusive. This one here tells you that 5 is inclusive. Union 3 is inclusive, then to positive what? Infinity. It means that any value greater than 3 this inequality will be satisfied. Any value less than or equals to -5, this inequality will be satisfied. But within this interval -3 less than s and s less than 3, that means this interval here, this inequality is not what? Satisfied. So that is how you break it down, and then you check and confirm. So that would be the answer to this question. You say s is less than or equals to 5, s is greater than or equal to 3, and x is an element of this. Is that okay? Now, the next question says solve the equation. The equation they gave to you was 3 plus 2i divided by 1 minus 3i. So we have 3 plus 2i divided by 1 minus 3i. Now, if you want to solve this, you rationalize by multiplying both up and down by what we have, the positive sign of what we have under here. What we have under here is negative, so here becomes 1 plus 3i divided by what? Multiply both up and down by that, 1 plus 3i. Now, 3 times 1 will give us 3, plus 3 times 3 will give us 9i, plus 2i times 1 will give us 2i, 2 times 3 will give us 6. I times I is always minus 1. I times I is I square. I square is minus 1. I explained something like this in class. I times I square is what? Minus 1. All right? So please take note of it. I square is called iota square is minus 1. All we divide by. Now, if you have something like this in mathematics, when what you have here and what you have here is the same, just that the sign differs. It's called difference of 2 square. Now, to solve difference of 2 square, use this one to multiply what you have here. 1 multiplied by 1 will give us what? 1. Then use this 3 to multiply what you have here. Plus times minus will give us minus. 3 times 3 will give us what? 9. I times I will give us what? Minus 1. So this is what you are going to get for this one. It's called difference of 2 square. Is that okay? It's called difference of 2 square. Alpha. So at the end of the day, my dear student, what are you going to have? Come on, let me check it. At the end of the day, my dear student, what are you going to have? Said when you have something like this difference of 2 square, this I will multiply this I. This positive will multiply negative to give us negative. 3 times 3 will give us what? 9. I times I will give us minus 1. Is that okay? Now, this is only possible when you have something like A plus B bracket A minus B. That means what you have here is the same as what you have here. The only difference is the sign. Is that okay? So this will give us 3 plus 9i plus 2i will give us what? 11i. 6 times minus 1 will give us what? Minus 6. Divided by 1. Minus times minus will give us what? Positive plus 9. So 3 times minus 6 will give us what? Minus 3 plus 11i divided by what? 1 plus 9 will give us how many? 10. So that is the solution to that question. Let me confirm. Of course, it's correct. Now, this can also be written as minus 3 all over 10 plus what? 11i divided by 10 as the correct answer to that question. It's a very simple one, right? Exactly. Let's see the next one. The next one is you are given this indicial equation and you are asked to simplify. Now, if you are given something like this, it's very easy. Firstly, we have to break down this 36 so that it will have a base of 6 raised to a particular power. Now, 36, my dear student, can also be written as what? 6 square bracket x minus 7 bracket 6x plus 12 is equal to 0. Now, this 2 and s can interchange. It's still the same thing because multiplication is mutually exclusive. It means 2 times x and x times 2 is the same thing. So this is going to give us 6, 2, bracket x. They are the same thing. Minus 7, bracket 6x plus 12 is equals to 0. Now, we can now say let p be equals to, supposed to be x. 6 raised to the power of x times 2 is the same thing. Are you getting it now? So we can say let p be equals to 6 to the power of x. Now what that means is that wherever you see p, wherever you see 6 raised to the power of x, put p there. So this equation now will now become p squared minus 7p plus 12 is equal to 0. Here will become p, here will become p. You put p here in these places. Are you getting the idea now? Exactly. Plus 12 is equal to 0. Now this equation, you have to simplify it using quadratic equation. What are those two values? Now when you multiply them, they will give us plus 12p squared. But when you add them, they will give us minus 7p. My dear student, those two values, they are 4p minus 4p minus 3p. Plus 12 is equals to 0. Because minus 4p minus 3p will give us minus 7p. Minus 4p times minus 3p will give us 12p squared. Because the general idea is that we usually use this p squared to multiply what we have there. All right? That's the general idea. The general idea is we usually use this p squared here to multiply this 12 to give us 12p squared. Is that okay? Then we'll find two values in such a way that when we multiply them, they will give us this 12p squared. And when we add it, they will give us minus 7p. Is that okay? Now, what is it called? The common thing between p squared and 4p, of course, is p. So this gives us p minus 4 minus 3 bracket p minus 4 equals to 0. Now, this gives us p minus 4. According to basic mathematics, when you have something like this, you collect 1 in the bracket and then you collect this p and this minus 3 outside here. Everything will give us what? 0. So at the end of the day, p minus 4 will be equal to 0 and p minus 3 will be equals to 0. So p now will be equals to 4 and p will be equals to 3. But recall, we said p is 6 raised to the power of x. That was what we said. But p now is equals to 4. So you're now going to say when p is equals to 4, wherever you see p, put 4 in this equation here. Wherever you see p, put what? 4. So this is going to give us what? 4 is equals to 6 to the power of x. You can't solve this without adding logarithm. So you are going to find the log of both sides. So here will give us log 4 is equals to log 6 to the power of x. This x comes back. This will give us log 4 is equals to what? X log 6. Because according to in this logarithm, if you have a power like this s can come to the back here. Are you getting it? So it gives us x log 6 equals to log 4. Now, we can still write this as what? X log 6 is equals to log 4. It's still the same thing. So to get x, divide both sides by log 6. So this cancel this. X will be equals to log 4 over log 6. You can press that in your calculator, log 4 over log 6. Did that give us 0.7? Let me press. log 4 log 6, 0.7737. So that is the answer to your x for the first one. Then for the second one, when p is 3, right? It will not be 3 because p is equal to 6 over 6 to the power of x. So when p is 3, it will not be, okay, there's no space here. It will not be what, my dear student? 3 is equals to 6 to the power of x. You're also going to find the logarithm of both sides. Let me put it here. If you find the logarithm of both sides, what would this now give to us? Log 3 is equals to log 6 to the power of x. Take this x to the back according to the law of logarithm. My dear student, what would this give to us? Log 3 is equals to x log 6. So to get our x, divide both sides by log 6. Divide both sides by log 6. This cancel this. X will be log 3 divided by log 6. So punch this in your calculator. Place of this log 4, just change it to log 3. The answer is 0.613. So x is 0.6131. All right, so our x is 0.6131 or 0.7737 or 0.7737. So this is how to solve an equation like this. Let us see the next one briefly, my dear student. The next one, this question is a very long and stupid question. So I don't even know this particular question. I don't know where this question actually came from. But then we are going to simplify and we are still going to get the answer. I think it's the longest question we ever had here. The question says resolve the expression into its simplest partial fraction. Simplest but not simple. So we have x minus 2, my dear student, divided by what? X squared plus 1, then bracket x minus 1 squared. Now, this, according to the laws in partial fraction, whenever you have something like this, I can rewrite this in such a way that you can put, I really want to follow what we have here so I will not make a mistake. Okay, this whole thing can also be written as, this whole thing can also be written as, it's still the same thing. Because multiplication is mutual. Are you getting it? Can also be written as what? X minus 1 square bracket s square plus 1. It's still the same thing. And in partial fraction, if you have something like this, you can say a over, this one is repeating terms. Are you getting it? Because of its square. It's a pattern in partial fraction. Yeah, if you have something like this, you are going to write it as x minus 1 plus, then you write b, and then here will be x minus 1 square. Had it been here is raised to the power of 3, you will now have plus c all over what? X minus 1 raised to the power of what? 3. It's called repeating terms. Are you getting it now? Partial fraction involving repeating terms or repeating powers, something like that. Now, this is plus. Now, if you have a partial fraction that has a quadratic or that is to the power of 2, you usually use cx plus d divided by what? S squared plus 1. All right, this is the way to express this thing. You are going to be taught in partial fraction proper. Now, if you have something like this, my dear student, at this point in time, the next thing we ought to do is to find the LCM. Now, the LCM of everything we have here, my dear student, is still the same thing with what we have here. So that is going to give us x minus 1 square bracket what? S square plus 1. It's the same thing because it was actually this one we broke down to give us, it was this one we broke down to give us all of this. So this one here can divide all of this. So it's the LCM, lowest common multiple. Now, We are now going to use this one to divide each of these terms we have here. So we have this whole thing here divided by x minus 1. If x minus 1 divide this, it's going to cancel what square from here. So what are we left with? X minus 1 bracket what? X squared plus 1, which we are going to use to multiply a. I mean, this one is divided by this. It's going to cancel one square. You know this one is square, it's two of them now. So what we are going to be left here with will be what? A bracket. When we divide it by this, one square will go. So we'll be left with what? X minus 1 bracket what? S squared plus 1. Plus, if this divide this one here will cancel this. So what are we left with? S squared plus 1 multiplied by b, because you multiply by what you have there. So this will give us s squared plus 1. Now, my dear students, if this and this divide, this s squared plus 1 will cancel. So what are we left with? We are left with cx plus d bracket. Of course, I said this one and this one will cancel. So we have s minus 1 squared. So we have x minus 1 squared. All right? This is what we are going to have. Now, at this point in time, these two places, they are the same. What we have here and what we have here is the same. So they can cancel out since they are on different parts of the equation. Now, when they cancel out, my dear student, what we are left with will be x minus 2 is a bracket x minus 1 bracket s squared plus 1 plus b bracket s squared plus 1 plus cs plus d bracket x minus 1 squared. Is that okay? That is what we are going to have. Now, for benefit of that, I like just doing something. Now, let us say let this x minus 1 be equals to 0. If x minus 1 is equals to 0, it means if you take this one to this other side, my dear student, x will be equals to 1. Put this x equals to 1 into this entire equation and see what it will give to us. So put x is equals to 1 into this entire equation and see what it will give to us. So that will give us what? 1 minus 2, because we said we are putting it into this equation, which is x minus 1. Wherever you see x, put what? 1. 1 minus 2 equals to a bracket 1 minus 1, then bracket what? 1 squared plus 1 plus what? b bracket 1 squared plus 1 plus we have cx plus d, which is what? C multiplied by 1 plus d, all right, bracket what? 1 minus 1 squared. Now, you now discover that 1 minus 2 will give us what? Minus 1. 1 minus 1 will give us 0. Everything here multiplied by 0 will give us what? 0. Now, 1 square is 1 plus 1 is what? 2. 2 times b is what? 2b. So this one, first one will give us 0 plus 2b. Now, 1 minus 1 will give us 0. 0 square is 0. 0 multiplied by everything here will turn out to be what? 0. So plus 0. So we can say minus 1 is 0 plus 2b plus 0. Of course, 2b plus 0, everything here will give us what? 2b. So divide both sides by 2. This cancel this. Our b, my dear student, is minus 1 over 2. So that is our b. We've gotten our b. But we have a lot to look for. We have a to look for, we have c to look for, we have d to look for. So the next step now, my dear student, is to open through these brackets you have here. Each of them, just open them through and see what is going to give to us. So let us take a. Open a through first and see. Are you getting it? So taking a is what? X minus 1 s squared plus 1. If we open this will give us a bracket S squared times S, S times S squared will give us what? S cubed. S times 1 will give us what? Plus X. Minus 1 times S squared will give us what? Minus S squared. Minus 1 times 1 minus 1 times 1 will give us what? Minus 1. All right? And this multiplied by A, this will give us what? AS cubed plus what? AX minus what? AS squared minus A. We are using A to multiply through everything here. So that is for A. Now let us do for B. For B is B bracket S squared plus 1. Let's take it. So this gives us B bracket S squared plus 1. This one is very straightforward and simple. B multiplied by S squared, that will give us what? BS squared plus this multiplied by this will give us what? B, because B times 1 will give us B. Now, the next one now, which is the last one, is CS plus D bracket X minus 1 squared. Now, that will require us to think a little bit. So we have CX plus D bracket what? X minus 1 squared. So first of all, we are going to do X minus 1 squared. So this will give us CX plus D bracket X minus 1 squared is X minus 1 bracket what? X minus 1. So this will give us CS plus D bracket X times S will give us what, my dear student? S squared. S times minus 1 will give us minus S. This will give us minus S and then plus 1. If you do normal mathematics and expansion, this multiplied by this S squared. S times minus 1 minus X. Minus 1 times this X here minus X. Is that okay? Then minus 1 times minus 1 will give us plus 1. Now, at the end of the day, this will give us CS plus D bracket S squared minus S will give us what? Minus 2X plus 1. Now, you are now going to use this CS now to open through this again. That will give us CS multiplied by S squared. That will give us what? CS cubed plus this multiplied by this will give us 2CS squared. All right? 2CS squared plus this multiplied by this will give us what? CS. Is that okay? Plus 2CS. This is supposed to be plus or minus. Here will give us minus 2CS. This CS cubed minus 2CS squared plus what? CS. Then for the D, we are now going to use D now to open through. What we use to open through is what? CS. We use CS to multiply this, CS to multiply this, and CS to also multiply this. So we want to use D now. We use D to multiply this, use D to multiply this, and then use D to multiply 1. So my dear student, what will it be? Plus D multiplied by this will give us what? DS squared minus this multiplied by this will give us what? 2dx. Then D multiplied by 1 will give us what? Plus D. Is that okay? I think that was what we had here. DS squared minus 2dx plus D. Exactly. So these are the expansions of everything we had here. Are we getting it now? So we are going to add all of them together now, and let us see what that will give to us. Let us see what that will give to us, my dear student. So we have expanded everything. I can erase this part now. Can write, then erase this part. So that means what we are going to have now will be x minus 2. Told you that this is a very long and nonsense question. X minus 2 will be equals to, what was that for A? We expanded, because S minus 2 is equals to A bracket this. We've expanded this. What did we get from the expansion? 8x to the power of 3 plus AS. So this gives us AS to the power of 3 plus AS minus AS squared. Are you getting it? And then minus what? A. Exactly. Then the next one is that of B. What do we get for that of B? B is what? BS squared plus B. So this one is not quite much. So we have plus BS squared plus B. Are you getting it? Plus that of C is the longest. Did I keep the expansion for? Okay, that is what we have under here. So that will give us CS cube, okay, minus 2CS square plus CS plus DS square minus 2DS plus D. Are you getting it now? Plus D. Now, at this point in time, you are not going to rearrange them. We are not even half done with this question. So x minus 2 will be equals to, when we rearrange, let all the ones that have cube come together. So this one will give us AS cube plus, there's another one that has cube here, which is this. So we have plus CS cube. Let the one that have S square come together. So we have AS square plus BS square minus 2CS squared plus DS squared. Are you getting it now? Then the one that has only X, let them come together. The ones that have only X, we have AS. Sure, that one again, do we have? We have CX and then we have DS. So we have plus AX, all right, plus CS minus 2DX. Then let the constants come together. The constants we have here are minus A plus B plus D. C does not have any constant. So minus A plus B plus D. All right? Think so? Think so? We have to be very sure because anybody could have made mistake in this particular question. Okay, I jumped that step here because they have that time to start looking and then one after the other. Okay, minus A plus B plus D. Okay, it's very correct. Now, at this point in time, we are now going to compare both sides of the equation. Now, how do we compare? If you look at this equation, there's no S cube. Are you getting it? And since there's no S cube, anything that has S cube here, you just take their coefficient and equate it to 0, since there's no S cube. So what are we going to have here? What we mean is, since there is no S cube, it's supposed to be this equation now. It does not have S cube, so it will be 0 S cube plus, it does not have S square, so it will be 0 S square plus X minus 2. I mean now, because 0 times 0 and everything here will still give us S minus 2. This is how it is done. So you are now going to compare. There's no S cube here, so it's 0. So you now say, compare all the S cube here. Since there's no S cube here, you put it 0 S cube will be equals to what? AS cube plus what? CS cube. All right? Now, at the end of the day, what is common between here and here? S cube and S cube. So here will be 0 S cube will be equals to, S cube is common here, so take it out. You have A plus what? C. This S cube cancel this S cube. So 0 will be equals to A plus C. So A plus C, my dear student, is equals to 0, equation 1. That's the first thing you do. Then the second one too, there is no S square. So you say 0 S square is equals to, the ones that have S square here are what? Minus, what is common among all of them? S square is common. So we can take the S square out here, my dear student. So here we give us S square. Then what is left here is what? Minus A plus, what is left here? Remove the S square, B. What is left here is what? B minus 2C plus D. All right? This one cancels this one. So we can say that our minus A plus B minus 2C plus D is equals to what? This 0 here. Minus A plus B minus 2C plus D is equals to 0. That is very correct. Now the next one will be for x. For x, x is equals to, of course, if it's s standing on its own, it means 1 is part of it. S will be equals to, for all the ones that have x is common among them. So you take the x out. What do we have left here? A plus, what do we have left here? C minus 2d, which is this minus 2dx. But because s is common, we've taken it out. So s cancels s. What are we left with here? 1 will be equals to what? A plus c minus 2d. So we have a plus c minus 2d is equals to 1. This is equation 2. This is equation 3. This is a very long question and it will be very difficult for some of you to really understand. But if you are following through, glory be to God. All right. So that is for that. Now the last one is our constants. Now for the constant, what we have for the constants are minus a plus b plus d. These ones that do not have x are our constant. So minus a plus b plus d is equals to, the constant we have at the left hand side is minus 2, which is this one that does not have x attached to it. So you say this is equals to minus 2. This is equation 4. So we have 4 equations. Now how do we solve the 4 equations? The first one we have is a plus c is equals to 0, equation 1. The second one is minus a plus b minus 2c plus d, think so, minus 2c plus d is equal to 0, equation 2. Then the equation 3 is a plus c minus 2d, a plus c minus 2d is equals to 0, equation 3. All right? And then lastly, you have the last one, minus a plus b plus d minus a plus b plus d is equals to minus 2, equation 4. All right? So at this point in time now, you are now going to remember that we've already solved for b. When we started, we say b is what? Minus half. So we come here, remember b is minus half. So a plus c is 0. If a plus c is 0, from equation 1, a plus c is 0. That means a is minus c. Are you getting the idea now? A plus c is 0. A is what? Minus c. Now, having gotten a as minus c, what does that mean? You may not even necessarily go through that. From equation 1, a plus c is 0. Now, looking at equation 3 says that what? A plus c minus 2d is equals to, supposed to be a plus c minus 2d is equals to 1, not 0. Check it. A plus c is equals to 1, equation 3, right? Is equals to 1. So a plus c minus 2d is equals to 1. But we already said our a plus c is 0. So wherever we see a plus c, we can put 0. So here it gives us 0 minus 2d is equals to 1. 0 minus 2d is what? Minus 2d is equals to 1. Divide both sides by 2. I mean minus 2. My dear student, d will be what? Minus 1 over 2. So you got to your b, minus 1 over 2. Go to your d, it's minus 1 over 2. Now the next one will be to get our c. It's very easy. How do we get c? Or we can even get d self. All right? Can get d. Which of them did I actually get here next? I got a next. From here, we have that minus a plus b plus d is minus 2 from equation 4. All right? So we've already gotten our b minus half, d minus half. So minus a will be b is minus half, minus d is what? Minus half. Everything is equals to minus 2. Minus half is 1. It's like half plus half. So we have minus 1 equals to minus 2. Take this negative to this other side. What will it now become? Minus a will be what? Minus 2 plus 1. Abina. So minus a will be minus 2 plus 1 is what? Minus 1. Cancel both sides with negative. So a is equals to 1. So my dear students, our a is equals to 1. Now, if a is equals to 1, what is the last thing we are looking for? C. But we said a plus c is what? 0. So from equation 1. So if a is 1, 1 plus c will be equals to 0, and c will be equals to minus half. So c is equals to minus 1. From the initial equation, what was the initial equation given to us? Said s minus 2 is equals to a plus this. That is a over x minus 1 plus b over x minus 1 square plus cs plus d divided by s squared plus 1. That was a partial fraction, Abi. That was the partial fraction, cs plus d all over x squared plus 1. We've gotten all our values, so we can now put them into the equation. A is 1, c is minus 1, b is minus half, d is minus half. Putting them into this equation, my dear students, what are you going to have now? So the partial fraction will be 1 over x minus 1 plus, now b is negative sign, so that negative will affect its positive here, so it will be minus. You can decide to put 1 over 2, but these two can come down to give us minus 1 over 2 bracket what? X minus 1 square plus cs plus d. C is what? Minus 1. So that minus 1 will definitely affect this negative sign, positive sign here. So here will give us minus what? 1 times x, which is the same thing as what? X. So we can put it as minus 1x. D is minus half, minus 1x minus half divided by what? S squared plus 1. So final answer to this very long useless question will be x minus 1 minus 1 over 2 bracket x minus 1 square minus x bracket minus 1 over 2 divided by what? S squared plus 1. And that is the answer to the question. It's a very long, useless question. But I know most of you may not really understand this one because it requires so many mathematical cracking and jargons. You could just copy it and we'll do more simpler ones that will come in the exam. If you get a question like this in the exam and you are wasting your time to solve, I won't even advise you. Is that okay? Now, next question says, in how many distinct ways can 5 red balls, 4 yellow balls, and 1 blue ball be arranged in a row? 5 red, total number of balls, 4 yellow, 1 blue. Total number of balls is how many? 10 balls. Out of the 10 balls, 5 are yellow. So to get the number of ways, this is a very simple question, potential question that will come, is 10 factorial. Since we have 5 red, all over 5 factorial times, we have 4 yellow, all over 4 factorial times 1 blue, all over 1 factorial. Now, my dear students, 10 factorial can also be written as what? 10 times 9 times 8 times 7 times 6 times 5 factorial, because we have 5 under times 6 times 5 factorial. We ended at 5 factorial because we also have 5 under that we can use to cancel what we have on top. Times this 4 factorial can be expressed as 4 times 3 times 2 times 1 times 1 factorial is still the same thing as what? 1. So 5 cancels 5. Now, can you decide to use 4 and 2 will give us what? 8. So you can cancel 8 on top. 4 times 2, 8. You cancel the 8 on top. Then we are left with 3. 3 going to here. That will give us what? 3. So at the end of the day, what are we going to have? 10 times 3 times 7 times 6. 1,000. So the number of ways of arranging this be 1,260 ways. All right, that is number of ways of arranging what we have there. All right, number of ways of arranging that. Now let's see the next one. The next one says, given that 4, 12, x, y, 324, 9, 72 is a geometric sequence, find the sum of x and y. Now, the term in a geometric sequence is given by a arrow n minus 1. Now, of course, the first term is 4 from this question. Now they ask you to find the third term. Before you can sum x and y, you must look for the value of x and y. And x is the third term when n is 3, and y is the fourth term when n is 4. Now what will be our common ratio? The common ratio is gotten by dividing the second by the first. So that will give us 12 divided by 4, since they told you that it's in a geometric sequence. 12 divided by 4, my dear student, will give us 3. That is how we got our arrow. Now we are looking for the third term. So T3 would be equals to, when n is equals to 3. First term is 4, because the formula say a first term, bracket arrow is 3, right? N is also 3 minus 1. All right? Now, at the end of the day, this will give us T3 will be equals to 4, then bracket 3. 3 minus 1 is what? 2. 3 squared is what? 9. 9 times 4 is how many? 36. So T3 is 36. Now let's look for T4. T4 will still follow the same. First term is 4. The common ratio is arrow. The n, this term, n is equals to 4 for the fourth term. So 4 minus 1. So T4 will be equals to 4 bracket 3. 4 minus 1 is what? 3. 3 raised to the power of 3 is what? 27. So we have 4 times 27. T4 will give us, this is 8. And this is, I think, 108 also. Yeah, I think that should be 108. 4 times 27 supposed to be 108. Yeah. So to get the sum of x and y, is this written as T3 plus T4. So that will give us 36 plus 108. So we have 36 plus 108, which gives us 144. Is that okay? That is that for that particular question. Let's see the next one. The next one says simplify this. This is a very simple question. Now, we have 7x to the power of 6 times 7x to the power of 5. You use this 7 to multiply 7. That will give us 7 times 7 times, when the bases are equal, collect 1 and add the power. So this gives us x, 6 plus 5. 7 times 7 will give us 49x. 6 plus 5 will give us what? 11. Now, the next one is this. This one, 18 raised to the power of 18x raised to the power of 15 divided by 3x to the power of 7. Now for this, it will be 18 divided by 3. Then we have x raised to the power of 15 divided by s raised to the power of 7. 18 divided by 16, or 18 divided by 3 rather, is 6. So we have x. When the bases are equal and division is in between them, collect 1 and then subtract the power. So this is going to give us 6x. 15 minus 7 is what? 8. And that is the solution to that question, 6x raised to the power of 8, which we have solved. All right? Exactly. Let's see the next. If z1 is 6 plus 8i and z2 is minus 4 minus 5i, find z1 times z2. Now, this is normal multiplication of complex number. So z2 minus 4 minus 5i. So to find z1 multiplied by z2, it becomes 6 plus 8i multiplied by minus 4 minus 5i. 6 times 6 times minus 4 will give us minus 24. This multiplied by this will give us minus 30i. Normal division, now use this 6 to multiply what we have here. Then use this one to also multiply this. Then we are going to use this one here, 8i to multiply minus 4, which will give us minus 32i. Then use this 8i to multiply 5. That will give us minus 40i squared. Told you that I times I or I squared is the same thing as what, my dear student? The same thing as minus 1. All right? So this will then give us minus 24 minus 30i minus 32i. That will give us 62i. Minus 1 times 40 minus 40 will give us plus 40. So we have minus 24 plus 40 minus 62i if you rearrange. Minus 24 plus 40, my dear student, that will give us what? 16 minus 62i. And that is the answer to that question. It's a very simple one. A very simple question. Now, we have another question here that says, express this in polar coordinate form. Now, this is under complex number. I believe you've not been taught complex numbers at the time you are taking this lecture. But let me just give you a little idea. The polar form of a complex number is given by z is equals to r bracket cos theta plus I sine theta, where r is the modulus or the magnitude of the complex number. How do you get the magnitude of the complex number? All you need to do to get r, it is the square root, like normal when you are finding magnitude of vector, of what you have here, which is 1 square plus the square of what you have attached to I. What you have attached to I is the square root of 3. So this gives us square root of 3 also squared. So our arrow will be equals to 1 square is 1 plus this square, cancel this square root from here, plus 3. So our arrow will be the square root of 1 plus 3 is how many? 4. Arrow will be equals to 2. Now, how do you get theta? Theta, tan theta is always equals to what you have here over what you have here. That means what you have in the imaginary part over what you have in the real part. Every complex number has a part called the imaginary part. The part that carries this I is the imaginary part. All over the real part is the one without the I. So this will give us root 3 divided by 1, because it's usually the imaginary part without the I all over the real part. So my dear student, tan theta will be root 3 over 1. This is the same as what? Root 3. So to get theta, of course, theta will be the tan inverse of root 3. So press that in your calculator and see what that will give to us. It's a very simple something. Shift tan root 3. Is it giving me not supposed to give me that? Okay, my distance is in rad. For fear, convert to degree. Shift tan root 3. That will give you 60 degree. So it means our theta is 60 degrees. Although this one, there is a way they used to get the theta. I'm going to teach you that later on. All right. We have different quadrants. We have what? Different quadrants. I'm going to teach you that entirely in a separate lecture on the complex number. But for this one, it's actually correct like this. All right. So we are now going to put that into this equation. We've gotten our theta, we've gotten our arrow. So the polar form of this vector, of this complex number will be arrow is what? 2. Then cos theta is what? 60 degree plus what? I sine 60 degree. This is the polar form of the vector. So you don't really need to do anything here. This is the answer to this question. Is that okay? Let us see the next one. Still the same question. The next question says sine x is 8 over 17 within the interval 0 is less than or equals to x and s is less than or equal to 90. Find the value of this. Now, my dear student, there is a trigonometric identity that says sine square x plus cos square x is always equals to 1. There's a trigonometric identity that says this, that sine square s plus cos square s equals to 1. So to get our cos square s or cos s, let this sine square s cross to this other side. If it does cross, it's now going to give us what? 1 minus what? Sine square s. To find cos x only, find the square root of both sides. If you find the square root of what we have here will remain cos x. Then square root of this is going to give us square root of 1 minus what? Sine square x. So it means cos x is equals to the square root of 1 minus what? Sine square x. Is that okay, my dear student? Now, they've already given you sine x as what? 8 over 17. So what do you think our cos x will be? Wherever we see sine x, we put 8 over 17. So this will be the square root of 1 minus 8 over 17. But this one is squared. Sine x is squared here. So this is going to be squared too. So my dear student, cos x will be the square root of 1 minus 8 square is 64. 17 square is 289. All right? Exactly. So our cos x will be the square root of 1 minus 64 divided by, now we can find the square root of what we have here. What is the square root of 289 and 1? Of course, it's 289. So 289 divided by 1 is 289 times 1 will give us what? 289 minus 289 divided by this will give us 1 times 64 will give us 64. All right, exactly. So let's see what that will give to us. That will give us, when you subtract, this will give us 289 minus 64. That will give us 225, I guess. So 225 divided by 289. Let me plug my laptop. Now, my dear students, what do you think they come in. Hey, hey, hey. Wahala don wear bossa. All right, so we are solving until we got to a point where we had, I think, root 225 divided by, sorry, say full root. So we had root 225 all over 289. Now this can also be written as root 225 all over root 289. Root 225, my dear student, that will give us 15. Root 289, that will give us what? 17. So it means that our cos x, which in this case is also cos theta, is what? 15 over 17. Is that okay? Now what we are going to do now is to substitute all of this into this equation we have here. Is that understood? Now what is our sine s? Sine x, this thing is misbehaving now. Let it just calm down small. It's my hotspot. Hotspot is on. Let me off it first. Coming. Off. All right. Now, sine theta, my dear student, is 8 over 17. Is that okay? Sine theta is 8 over 17. So we have 8 over 17. Now, cos theta is 15 over 17. Now we have this. They say we should find cos theta minus sine theta all over sine squared theta. So how do we find that? Cos theta is 15 over 17. Sine theta is 8 over 17 all over sine square theta, which is what? 8 over 17 square. What's the LCM of these two here? 17. So we have 17 divided by 17 divided by 17 is what? 1. 1 times 15 is 15 minus 17 divided by 17 is 1 times 8 is what? 8. Everything divided by 8 square is 64. 17 square is 289. Is that okay, my dear student? 15 minus 8 will give us what? 7 over 17 divided by 64 over 89. All right? Which should be 7 over 17 times 289 rather. 289 divided by 64. Think so? Now, 17 going to here 1, 17 going to 289 will give us 17. All right? So that 7 times 17 would be equals to what? 119, think 119 divided by 64. And that is the answer to this question. Let's see the next one. The next question says, find the seventh term of the series. This is a very simple question. Find the seventh term of the series. The question was actually find the series of the seventh term. Yes, no, that question does not make sense. So if they say find the seventh term of the series, it means they ask you for what? T7. It is unknown. But Tn, the series, was given as what? N plus 1 square minus 2n. So the seventh term, which is T7, it means our n is equals to 7, which is equals to 7 plus 1 square minus 2 times 7. 7 plus 1, my dear student, is equals to what? 8 square minus 2 times 7 is how many? 14. So T7 will be equals to 8 square is 64 minus 14. So T7 will be 64 minus 14 is how many? 50. Is Is that okay? So that is the seventh term of this series. This question, the way they ask it in that particular this thing was not actually correct. It doesn't make any sense that way. Is that okay? Now let us see the next question briefly. The next question say evaluate this. Now there's a lot of logarithm that say if you have log x to base b, which is equals to a, your x is equals to b to the power of a. So if you have log to base 10 of x squared minus x minus 7 is equals to 0.1, in this case, our x is this thing here. So that would be what? S squared minus x minus 7 would be equals to, in this case, our b is this 10 here. So 10, our a is what? 0.1, 10 raised to the power of 0.1. So that at the end of the day, this will give us s squared minus x minus 7 is equals to 10 raised to the power of 0.1 is 1.26. Now, for us to form a quadratic equation, this 1.26 we have to cross to this side. If 1.26 cross, what are we going to have? S squared minus x minus 7 minus 1.26 is equal to 0. So s squared minus x minus 8.26 would be equal to 0. Now we are going to use the quadratic equation formula to solve. X will be equals to minus b plus minus the square root of b squared minus 4ac all over 2a. Let me put it up here. Quadratic equation say x is minus b plus minus the square root of b squared minus 4ac all over 2a. Now, from this question, our a is equals to 1. A is the coefficient of s squared. S squared is standing on its own, so the coefficient is 1. B is the coefficient of x, which is this. X is, this is the equation we are actually working with, the same thing. X is having minus 1 as its coefficient, so you have minus 1 there. Then C is equals to minus 8.26. This is actually the equation we are trying to solve. X has 1 as its coefficient, you can't see it. This one also has 1 when it's standing on its own. Because of this negative, you put negative 1 for B. Y C is this constant here, 8.26. Now put them into this equation. X will now be equals to minus bracket, minus B is 1, minus 1, plus minus the square root of minus 1 square minus 4. A is what? 1. C is what? Minus 8.26. Everything all over 2 times 1, because A is 1. Now, my dear student, when you simplify this, your x is going to give us 1, because minus times minus is 1, plus minus the square root 1 square, minus times minus is negative, it's positive rather, so we have 1 plus, when you multiply what you have there, you're going to give us 33.04, all divided by 2 times 1 is what? 2. So our x, my dear student, will be 1 plus minus the square root. 1 plus this will give us 34.04, all divided by 2. And x will be 1 plus minus, okay, it's the same thing. So we are going to have 1, let's take the one after the other. 1 plus root 34.04 divided by 2, and 1 minus root 34.04 divided by 2 from your normal quadratic formula. Now, when you simplify this, press it to your calculator. This will give us 3.42 and x minus 2.42. Any one of these actually goes as the answer to this question. Is that okay? Let's look at the next one. The next one is says solve the equation in solved form. in surd form. Now, this equation in surd form is 2 root 2 minus 3 divided 2 root 2 plus 1. When you have anything like this given to you in surd form, you rationalize both the up and the down by the conjugate of what you have at the denominator. What do I mean by that? This denominator, anything you have on the denominator, just change the sign. So if here is positive, here will be what? Minus. Use what you get to multiply both up and down. Since here is positive, you are going to have 2 root 2 minus 1. Use that to multiply both up and down. Is that okay? So this will be times 2 root 2 minus 1 divided by 2 root 2 minus 1. Use this to multiply this, my dear student. First, 2 root 2 multiplied by 2 root 2. 2 times 2 will give us what? 4. Times root 2 times root 2 will give us what, my dear students? 2. Root 2 times root 2 will give us 2. Then use this 2 root 2 to multiply minus 1. This will give us minus first. 2 root 2 times 1 will give us 2 root 2. 3 times 3 root 2. We are now using this minus 3 to multiply now. 3 times 2 root 2 will give us 6 root 2. Then minus 3 times 1 will give us what? Plus 3. Divided by, I told you that when you have something like this is difference of 2 squared. Use this one. Whenever you have something like this that both of them are equal, the only difference is their sign, use this one to multiply this, and then use this one to multiply this. Use this to multiply the first one from here to multiply the first from here. Use this. This is only applicable when they are the same, but the sign differs. Is that okay? So this will give us 2 root 2 times 2 root 2. That will give us what? 4 times 2, because I told you 2 times 2 will give us 4. Root 2 times root 2 will give us 2. Plus, this will now be minus difference of 2 squared. 1 times 1 will give us 1. Is that okay? 4 times 2 will give us what? 8. So this will give us 8 minus 2 root 2 minus 6 root 2 plus 3 divided by 4 times 2 is 8 minus 1 is what? 7. All right? Now, at this point in time, minus 2 root 2 minus 6 root 2 is minus 8 root 2. Now, 3 plus 8 here will give us 11 minus what? 8 root 2. Because 3 plus 8, first of all, give us 11. Minus 2 root 2 minus 6 root 2 will give us 8 root 2 divided by 7. So this is the answer to this question. Or you could say 11 over 7 minus what? 8 root 2 all over 7 is the correct answer to this question. Okay. Now we have this question that says use the de Moivre's theorem to find all values of this. Now, first of all, you have to know what the de Moivre's theorem is all about. This one is for what is it called? For complex numbers. Now, the de Moivre's theorem says zk, complex number, is equals to r to the power of n in bracket cos theta plus 360 multiplied by k, all right, all divided by n plus I sine theta plus 360 multiplied by k, all divided by n. This is what the de Moivre's theory. This is in degree. De Moivre's theory in degree is all about. Now, how about in radian? Says r to the power of n bracket cos theta plus 2 pi k all to the power of n, right? Plus I sine theta plus 2 pi k all to the power of n. This is what the De Moivre's theorem is talking about. It's for complex number, where arrow is the modulus. Of course, I've taught you how to check the modulus. Our n is what they are asking us to find, the cube root. This is the cube root. Are you getting it? Which is 1 over 3. That is the power. Our n is our power. Are you getting it now? Which is 1 over 3 in this case. Now, because you are asked to find the cube root, this n here will be 3. Why this other will be what? Arrow 1 over 3. Is that okay? So, in this case, this formula now becomes, for cube root, this formula now becomes arrow 1 over 3, bracket, I would like to use this one up, bracket cos, bracket theta, plus 360k, all divided by 3. It is 3 because of this cube root here, 1 over 3, the cube root of, plus I sine, I'm going to teach you this one from scratch, 360k, all divided by what? 3. Is that okay? So that is what we have. Here k can have values 1, 2, 0, 1, and 2. So when they say find the possible values, the only thing that will change in this equation is 0, 1, and 2. Are you getting it? We are going to use this particular equation to solve. So just memorize the equation for now. This is the polar form of a complex number using the De Moivre's theorem. It's a French name anyway. All right? So k will be changing, but every other will remain. How do we find our arrow and theta? That is now what matters. Now, I told you earlier that your arrow is the square root of what you have at the real part, 1 square, plus what you have at the imaginary part, minus root 3 square. That is our arrow. It's the magnitude or the modulus. So arrow will be the square root of 1 square is 1, root 3 square. This root, we cancel this. Minus, we multiply each other because square means minus times minus. Everything here will give us what? Plus 3. Arrow will now give us what? Root of 1 plus 3 is how many? 4, which is 2. That's our arrow. How do we get our theta? Now, tan theta is always equals to what you have at the real part divided by what you have at the, what you have at the imaginary part. If you have a complex number like this, taught this in class recently, told you that this part is the imaginary part, this part is the real part. What you have at the imaginary part divided by what you have at the real part. Forget about the negative sign for now. So that will give us what, my dear student? Root 3 divided by 1. All right? So tan theta will be equals to root 3. So theta will be the tan inverse of root 3. Theta would be equals to, what do you think is the tan inverse of root 3? So we'll have shift tan root 3. That gives us 60 degree. Now this 60 degree, if you plot the graph, write this, so plot this this thing. If you plot the graph, this I here means the x-axis. This one here means the x-axis. Are you getting it? Why this one here, root 3, means the imaginary part, the real part is the x-axis, while the imaginary part is the y-axis. You must take cognizance of the sign. From what we know, here is positive y, here is negative x, here is positive x, here is negative y. So if you want to do 1 unit to the x-axis, it's somewhere around here. X-axis, because this is positive. Then root 3 units to minus y-axis because of this negative sign here. So minus y-axis is somewhere around here. If you trace it, there's something will fall like from here to here. Here is root 3. Here is what? 1. And this quadrant is called the first quadrant. This is called the second quadrant. This is called third quadrant. This is called the fourth quadrant. The angle you're actually looking for is the angle from the something you are looking you just saw now is somewhere around here. The angle you're actually looking for is the angle from this x-axis here to this position. That is the angle you are looking for. But the one they just gave to you, the one you just calculated, is this small one here, which is 60 degrees. So if you want to get the angle here, if this small place is 60, the total angle here is 360, right? So if here is 60, it means the other part will be 300 degrees. Are you getting it? So the real theta you are going to use for this question will be 300 degrees. I'm going to teach you under complex numbers. Is that okay? I'm going to teach you this under complex number. Detailed explanation. So that will be 300. So our theta we are going to use will be 360 minus 60. So theta will be equals to 300. Now, my dear student, if you've gotten theta as 300, what is the polar form of this vector? We say polar form normally is what? Is z is what? Arrow arrow cos theta plus what? I sine theta. Is that okay? Now, my dear student, for this case, z, what is our arrow? 2 cos 300, because theta is 300, I sine 300. This is the polar form of this complex number. Polar form. Now that you've gotten the polar form of this complex number, the next thing you need to do now, my dear student, is to get the values. I told you that you are going to use this formula. The de Moivre's formula is this formula here, where k will be changing. So the de Moivre's formula said what, my dear student? Zk is what? Arrow to the power of 1 over 3. Are you getting it? In big bracket, then what do you have here? Cos bracket theta plus 360 multiplied by k divided by 3, because we are talking about the cube root, plus I sine theta plus 360 multiplied by k, all divided by 3 also. So for the first one, the first k value, when k is 0, maybe wherever you see k, put 0 there. Our arrow is what? 2, then to the power of 1 over 3, because arrow is 2. We've calculated arrow initially to be what? To be 2. This is our arrow here. Are you getting it? The value for arrow, calculated it to be 2. So that will be 2.5. I don't expect you to understand this yet, cause until I teach you, brush you the full topic from beginning. Theta is 300 plus, now, this is 360 times k. Everything here will give us 0 because k is 0. 360 times 0 will give us 0. So we have plus 0 divided by 3 plus what? I sine, this is 360, 300 rather, because that's our theta, plus this k is 0, because we say when k is equals to 0, multiply by 360, which will give us what? 0. Everything here, divide by 3. So when k is 0, this will be 2 raised to the power of half, bracket, cos 300 divided by 3 will give us what? 100 plus I sine 300 divided by this will also give us what? 100. Is that okay? So this is our Z0. Of course, that is the answer to that question. Now, my dear student, this is in degrees. You can convert it to radian. Are you getting it? By multiplying by pi and dividing by 180. So Z0 will be 2 to the power of 1 over 3. Of course, which will give us 2 to the power of 1 over 3, will give us a particular answer. 1.26. 1.26, right? Multiplied by cos 100 plus I sine 100. If you want to convert this to degree, to radian, you multiply these angles by pi over 180. So Z 100 will be 1.26 bracket cos 100 times pi over 180 plus I sine 100 times pi over 180. Now, my dear students, 0 cancels 0. 2 here, 5. 2 here, 9. The same thing. Here will be 5 and 9. So final answer for Z0 will be 1.26, right? Cos what? Pi over 9. 5 pi over 9, not just pi. 5 cos 5 pi over 9 plus I sine 5 pi over 9. And that is the answer in radian. So this is the answer in degree. You can specify it for the first one. And this one is the one in radian. Now for the second one, that is when k is equals to 1. The one we did was when k is equals to 0. When k is equals to 1, everything still remains to be 2 to the power of our z1, 2 to the power of 1 over 3, bracket cos bracket 300 plus 360 times 1 now, divided by what? 3 plus I sine 300 plus 360 times 1, all divided by 3. All right? Now, this, I can erase this one. Hope you've written this one. For Z1, from when k is equals to 1, the other value will be, Z1 will be equals to, what did we get here? 1.26 bracket cos 300 plus 360 times 1. 360 times 1 is 360. So we have 360 plus 300 all divided by 3. That gave us 220. All right, cos 220 plus what? I sine. This other side will automatically still give us 220. This is in what? In degree. So to convert it to radian, you multiply by what? Pi over 182. So Z1 will be 1.26 bracket what? Cos 220 times pi over 180 plus I sine 220 times pi over 180. So Z1 will be equals to 1.26. This cancel this. This cancel this. What do you think can go again? 2 here, 11. 2 here, 9. Can any other thing go again? I think I actually did for the rest of them 5 over. I didn't do for the rest. I only did for the first one. And then this one will also be 11 over 9 pi. So this is bracket cos 11 pi. This is 11 over 9, or 11 over 9 pi plus I sine 11 over 9 pi radian. So this one is in radian. Is that okay? 220 divided by 180 11 divided by 9. They are the same thing. So that is for the when k is equals to 1. The last but not the least is when k is equals to 2. So wherever you see that, your z1 will be equals to, of course, 1.26 bracket cos 300 plus 360 in place of k multiply by 2 divide by 3 plus cos 300, I sine 300 plus 360 times 2 divide by 3. All right, so z1 be 1.26 multiplied by cos. Now, when you do this, everything here is going to divide by 3. 360 times 2 plus this divide by 3 will give us 340 plus I sine 340, which you can also convert to radian by multiplying by what? 180. Are you getting it? Pi divided by 180 and you get the answer. Is that okay? So that will be that for this particular question. It's a very simple question, but it requires you to think. All right? We'll see in the next one. All right, so we have the next question here, which says find the value of a and b if x minus 1 and 2x minus 4 are factors of this polynomial. Now, the polynomial that was given to you, my dear student, is px, which equals to 2s cubed plus as squared plus 4x plus b. Now, if they are factors, it means that if we substitute the value we get from here into this equation, it's supposed to give us what? 0. So what are the values we get from here, from the factors? X minus 1. Let us equate it to 0. So x is equals to 1. If there are factors, if you put this x is equals to 1 into this equation, the answer is supposed to give us 0. So we say p, in place of x, we put 1 there. Here give us 2 brackets, 1 to the power of 3, plus what? A brackets 1 square plus 4 brackets 1 plus b is equals to what? 0. Now, 1 raised to the power of 3 is 3, times 2 is what? 1 raised to the power of 3 is 1, times 2 is what? Is 2. 1 square is 1, times a is a. 4 times 1 is 4, plus b is equals to 0. Is that okay? 2 plus 4 is 6. So 6 plus a plus b is equals to 0. So we can say a plus b is equals to, take this 6 to this side, become minus 6. Equation 1. Is that okay? Then for the second one is 2x minus 4. So we put that one into the equation. 2x minus 4 is equals to 0. 2x will be equals to 4. If this one crosses to this side, divide both sides by 2, my dear student. X will be equals to 2. Put that one into this equation and see if it will and equate it to 0, right? So that will be p2 will be equals to 2 bracket 2 to the power of 3 plus what? A bracket 2 square plus 4 bracket 2 plus b is supposed to give us 0. 2 to the power of 3 is what? 8. 8 times 2 is what? 32 plus 2 square is what? 4. 4 times a is what? 4a plus 4 times a is 4a plus 4 times 2 is what? 8 plus b is equals to 0. Are you getting it? You sure? So I'm supposed to give us 2 raised to the power of 3 is 8. 8 times 2 is 16. All right, so yes, 16 plus 4a plus this is equals to this. This plus this, what would that give to us? 24. So 24 plus 4a plus b is equals to 0. Let this 24 cross to the other side. It becomes 4a plus b is minus 24. Equation 2. So we have two equations now. One of the equation is a plus b is minus 6. The other equation is 4a plus b is minus 24. Subtract this from this. What would that give to us? A minus 4a is what? Minus 3a. B minus b is what? 0. Is equals to minus 6 minus minus 24. That will give us what? Minus 6 plus 24, which is 18. So 1 minus 3a is equals to 18. Divide both sides by minus 3. Minus 3. This cancel this. A will be equals to minus 6. Is that okay? So that's our A. Now, if A is minus 6, and you had initially that A plus B is equals to minus 6, so it means A plus B is equals to minus 6. A is minus 6, so minus 6 plus B is what? Minus 6. B will now be equals to this minus 6 cross to this side, become minus 6 plus 6. So B minus 6 plus 6 will give us 0. So the correct answer to that question is what? 0. So A, for this question, A is minus 6, B is 0. It's a very simple question. Got in here. Now, this question here says, given that alpha and beta are the roots of this equation, form the equation whose roots are this. Now, if they give you something like this, alpha and beta are the root of the equation, what was the initial equation given to you? 3x squared minus x minus 5 is equals to 0. Now, one thing you need to look at when you are giving something like this is usually alpha plus beta. Alpha plus beta is usually minus b over a. And then alpha beta is usually c over a. How do we get a, b, and c? A is the term here attached to s squared. In this case, a is 3. B is the term here attached to x. In this case, it's just minus 1. And then c is the constant. The constant term here, my dear student, is what? Minus 5. So in this equation, alpha plus beta will be minus b over a, which is minus bracket b is minus 1, all over a is 3. So alpha plus beta, my dear student, will be equals to minus times minus is 1 over 3. So alpha plus beta is 1 over 3. Is that okay? Exactly. Now the next one is alpha beta. We said alpha beta is c over a. What is your c from this question? Your c is minus 5. Are you getting it? C is what? Minus 5. Now, what is your a? A is 3. So alpha beta is minus 5 over 3. Now, how do you get equation whose root we are given? It's usually s squared minus sum of roots, the sum of the roots you got, bracket s, plus the product of roots is equals to 0. Is that okay? S squared minus sum of roots, bracket s, plus the product of root is equals to 0. Now, they gave you two roots. They gave you this root and this root. So you must look for their sum first, then their product. Now, how do we look for the sum of this? What we are giving was 2 alpha minus 1 over beta plus, that means to get their sum, you add them together. 2 beta minus 1 over alpha. You can take these two together because they don't have fractions. So we have 2 alpha plus 2 beta. Then we have minus 1 over alpha, or minus 1 over beta first. The ones that have fraction, minus 1 over beta minus 1 over alpha. Now, what is common between these two? Of course, is 2. So we have 2 bracket what? Alpha plus beta. Minus is common here. So we open the bracket, which is 1 over beta plus 1 over alpha. Because if you take minus out, minus multiplied by this minus will give us positive inside here. So my dear student, when you get to this stage, what do? What is the LCM of alpha and beta? Of course, it's alpha beta divided by alpha beta divided by beta. That will give us what? Alpha. Alpha beta divided by beta, alpha, multiplied by 1. This will be alpha plus alpha beta divided by alpha will give us beta, multiplied by 1. That is beta. So what we have is 2 brackets what? Alpha plus beta minus what? Alpha plus beta divided by what? Alpha beta. This is our sum of roots for that first question. What was our alpha plus beta we calculated? 1 over 3. Right? Alpha plus beta is 1 over 3. So this gives us 2 brackets 1 over 3 multiplied by 1 over 3 divided by alpha beta was minus 5 over 3. Is that okay? So, all right, so we have 2 times 1 over 3. 2 times 1 will give us what, my dear student? This will give us 2 over 3 minus, then this 1 over 3 divided by 5 over 3. We can also write it as 1 over 3 times minus 5 or times minus 3 over 5, because if multiplication comes in, the 3 will come up, 5 will come down. So this cancel this. You have 2 over 3 minus times minus. That will give us positive 1 over 5. Are you getting it? Now, what is the LCM of 5 and 3? That is 15. 15 divided by 5, that will give us 15 divided by 3 will give us 5 times 2 will give us 10. 15 divided by this will give us 3. 3 times 1 will give us 3. And this will give us 13 over 5 as the answer to that question. So that is for the sum only. Then we now have to find the product. The product means you should multiply these two things together. What were the roots that we are given? The root that we are given were 2 alpha minus 1, 2 alpha minus 1 over beta. So to find their root, their product, 2 beta minus 1 over alpha. This one here is their sum. This will not be their product. 2 alpha times 2 beta. My dear student, what would that give to us? That will give us 2 alpha times 2 beta will give us 4 alpha beta. 4 alpha beta. 2 alpha times 1 over alpha. The alpha here will cancel the alpha. So 2 times 1 will give us minus 2. This one, 1 over beta times 2 beta, that will give us minus 2 also. Minus times minus will give us positive. 1 times 1 will give us 1. Beta times alpha will give us what? Alpha beta. So these are our products. Now, what is alpha beta minus 5 over 3? Put it into this equation. That will give us 4 brackets minus 5 over 3 minus 2 minus 2 will give us what? Minus 4 plus 1 all over minus 5 over 3. All right? This multiplied by this will give us minus 20 over 3 minus 4 plus this 1 all over 5 over 3 will give us plus bracket minus 3 over 5. All right? And then at the end of the day, this will give us 20 over 3 minus 4 minus 3 over 5. Is that okay? What is the LCM of 3 and 5? Of course, it's 15. So we'll have 15. 15 going to here times this will be minus 100. 15 going to here is 15 times 4. That will give us 60. 15 going to this is 3 times, or this going to 15 is 3 times 3. That will give us minus 9, which we now end up to give us minus 169 over 15. So that is our product. This is our product This is our sum. Now, what is the formula again? We say formula s squared minus what? Sum of roots bracket x plus the product of root is equals to 0. So what did we get as our sum of roots? We got 13 over 15. So we say bracket 13 over 15 bracket s plus the product of our root is negative minus 169 over 15 equal to 0. So s squared minus 13 times x will give us what? 13x divided by 15 plus times minus will give us minus 169 divided by 15 is equals to 0. You can multiply through by 15. If you multiply through by 15, this is going to give us 15s squared minus 13x minus 169 equal to 0. Why? Because if you multiply through by 15, 15 multiply this, 15 multiply here, this 15 will cancel it. More like here will be multiplied by 15, which will give us 15s squared. Here multiplied by 15, this 15 will cancel it. Here multiplied by 15, this 15 will cancel it. So we are left with only 169, 13x, and here everything will be equal to 0. So that is the equation for that first one. Now let's look at the second question. The second one says alpha over beta, beta over alpha. So we must first of all find the sum of that one too. So alpha over beta plus beta over alpha. We have to find the sum. Add them together. To add them together, what are we going to have? This will be LCM of alpha and beta will be what? Alpha beta divided by alpha beta divided by beta will give us alpha. Alpha times alpha will give us alpha squared plus alpha beta times divided by alpha will give us what? Beta. Beta times beta will give us what? Beta squared. So we have alpha squared plus beta squared divided by alpha beta. This alpha squared plus beta squared can also be written as, I'm going to teach you how we got this later, can also be written as alpha plus beta squared minus 2 alpha beta. There's a way to get it, which we are going to learn later. So my dear students, this will give us what? Alpha plus beta squared minus 2 alpha beta. All right? Substitute that now into alpha squared plus beta squared. What are we going to have? The sum will now be equals to alpha squared plus beta squared will have what? Alpha plus beta squared minus 2 alpha beta divided by what? Alpha beta. Is that okay? Now, what was our alpha plus beta as calculated? Still the same equation. As calculated was 1 over 3. So we have 1 over 3 squared minus 2. Alpha beta is minus 5 over 3. All divided by alpha beta is what? Minus 5 over 3. Is that okay? So when we simplify this, what did we actually get? Let me do that. 1 square will give us 1. So our sum, 1 square will give us 1. 3 square will give us 9. We have 1 over 9. Minus times minus will give us plus. 5 times 2 will give us 10 over 3. All divided by minus 5 over 3. Can write it this way, right? Now, what is the LCM of 3 and 9? Of course, it's 9. So sum will be equals to 9. 9 divided by 9 is what? 1. Times 1 is what? 1. 9 divided by 3 is 3. Times 10 is what? 30. Are you getting it? All divided by what? Minus 5 over 3. Now, 1 plus 30 give us 31 divided by 9. Now, this division sign can change to times. This 3 will come up, 5 will come down. So we have 3 over minus 5. This cancel this. Here will give us 3. This times 1. 31 times 1 will give us what? 31. All over minus 15. So this, our sum, is 31 minus 31 rather. 31 over minus 15, which we can write sum minus 31 all over 15. All right? So the next one now, aside that one, is the product. What we had was alpha over beta times beta over alpha. So the product means we multiply these two. Alpha, beta, this can cancel this can cancel the answer will give us 1. So the product, you don't even need to go far, is what? 1. What is the formula? Formula say s squared minus sum of roots bracket s plus product of roots equals to 0. What was our sum of roots, my dear student? Minus 31 over 15. So we have s squared minus bracket minus 31 over 15 bracket s plus 1 is equals to 0. So this gives us s squared. Minus times minus will give us plus 31 over 15x plus 1 is equals to 0. We can use 15 to multiply through so as to make it, are you getting it? If we use 15 to multiply through, my dear student, 15 multiplied by this will give us what? S squared. 15, we cancel this 15 under here. So we are left with 31x times this 15 here. Everything will give us 0. And that is the answer to that question. Then the last one for this question was 2 alpha and 2 beta. All right? So how do we get it? 2 alpha, 2 beta. Our sum will just be adding them 2 alpha plus 2 beta, which will give us the LCM. What is common there is 2. So we have 2 bracket what? Alpha plus beta. What is alpha plus beta? 1 over 3. So our sum will be 2 times 1 over 3, which is 2 over 3. So in this case, the sum is 2 over 3. Is that okay? Now what will be the product now? Just multiply them. 2 alpha times 2 beta. 2 times 2 is 4, so we have 4 alpha beta. What is our alpha beta? Of course, it's 1 over 3. So this gives us 4 bracket 1 over 3, which is 4 over 3. Is that okay? So, okay, no. Alpha beta is minus 5 over 3. For that back. So we have 4 brackets minus 5 over 3, which is what? Equals to minus 20 over 3. So our product minus 20 over 3. Is that okay? So let us find the equation. What will the equation be? The equation says sum of roots multiplied by x times the product of roots. So the equation now will be equals to, for this particular one, s squared minus sum of roots is 2 over 3x plus the product, of course, is minus 20 over 3. Are you getting it? Everything here is equals to 0. So multiply through by 3. This is 3s squared minus 2x minus 20 equals to 0. If you multiply through by 3, reason because 3 will multiply here, 3s squared. 3 multiply here, we cancel this 3 from here, so we have minus 2s. 3 multiply here, we cancel this 3 from here, so we have plus times minus minus 20. And that is how we got that answer. Is that okay? Now the next question is, in how many ways can the letters of the word statistics be arranged? Statistics. Let's write it out. Statistics. In how many ways can it be arranged? First of all, to find the number of ways, count the total number of letters here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 10 factorial divided by how many letters repeated themselves. S repeated himself 3 times. 1, 2, 3. So for S, you have 3 factorial. T repeated itself 3 times also, so you have 3 factorial. I repeated itself twice, so you have 2 factorial. What other thing repeated itself again? Don't think there is any other thing that repeated itself again. So this will give us 10 factorial, which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial, all divided by 3 factorial times. This 3 factorial can also be written as 3 times 2. 2 factorial can be written as 2 times 1. 3 factorial cancels 3 factorial. 3 times 2 will give us 6, so we can cancel 6 from here. 2 going to here give us 4. When you multiply everything you have here together, that will give us 50,400 ways. As the answer, it's a very simple one, right? Very simple. Let's look at this one. This one is the most simplest question here. Simplify the complex numbers. The complex number that we are giving to you here, minus 25. Now, my dear students, in complex number, this minus 25, you want to write it in short form. You can also write it as minus 1 times 25. Now, they taught you in short, or you were taught in short, that if you have something like this, it's still the same as what? Minus 1 times root 25. Root 25 is what? 5. So we have root 25 times root minus 1. Now, every one of you should know that root of minus 1 is equals to iota. Root of minus 1 is equals to what, my dear students? I, called iota. That I you always see in complex number will be writing is minus 1. Is that okay? So it means this will be what? 5 times what? I, which is 5 iota. Same thing applicable here. This is root of minus 9, which we can also write as what? We can write as 9 times what? Minus 1, whichever way you want to write it. This can also be written as root 9 times root minus 1. Root 9 is what? 3. Root minus 1 is what? Iota. So it becomes 3 times I, which is what? 3 iota. This is the most simplest question here. All right. And then the other one, I think this is the last question here. If A is equals to this, and B is equals to this, and C is equals to this, question says A is equals to what? A, comma B, comma C. B, A, comma B, comma C, comma D, comma E. And then C, A, comma B, comma C, comma D, comma E, comma F. Find A union B intersection A union C. So we have A union B is what? What these two things are, what A and B have in common without repetition, right? They have A in common, so you take it out. A, B, C, D, E, F. Not what they have in common, the union. Both what A has and what B has joined together without repetition. If there are some that A has, B does not have, they are bringing it together. That's why it's called union, more like marriage. Are you getting it? You are bringing them together. That's A union B. So the other one is A union C. That means what A and C have. Are you getting it? Without repetition, which is, of course, A, B, C, D, E, F. For B, it ended at only E. There's no F. Oh, God, do now. All right. So A union B intersection A union C, my dear student, is what these two have in common. And they have A, B, C, D, E in common. So the correct answer is A, B, C, D, E in common. It's a very simple thing. Then the other one is A symmetric difference B. Taught you that this symmetric difference means what? A minus B union B minus A. Meaning A is what? A, B, C. B is what? A, B, C, D, E. Are you getting it? It's definitely what A and B does not have in common. And of course, what they don't have in common is D and E. That is the symmetric difference. What they don't have in common. is D and E. They have A, B, C, D in common. Are you getting it now? But first of all, we have to look for A minus B. A minus B means, look at A. Anything that you have in B that is also in A, remove it from A. If you remove everything that you have in B that is also in A, you discover that A has nothing. A will now be an empty set. So it means A minus B is an empty set, because if you start cancelling, all what is in A are in B. So if you subtract B from A, meaning you are removing everything, then B minus A definitely mean, in case you are confused, this A minus B is more like A over B, like you are cancelling. So you have A, B, C, and then you have A, B, C, D, E, F. Cancel anything they have in common. This cancel this, this cancel this, this cancel this, and then write what is remaining on top. That is the meaning of A over B. There's nothing remaining, so it's an empty set. Is that okay? Why B over A means write everything in B, A, B, C, D, E, then everything in A, B, C. Cancel A, B, cancel B, C, cancel C. What are we left with on top is the answer. So what are we left with here? D, comma, E. My dear student, what will now be the union of both of them? The union A minus B, union B minus A is, this is an empty set. Only D and E is what we have here. This equals to what? D, comma, E. And this is the symmetric difference. So A symmetric difference of B is what? D, comma, E. And then for the this is the number one question here. Seemingly not correct, but we are still going to solve it regardless. Now, this number one question here is telling us the log to base 2 root 3 raised to the power of 5. Normally, there's no need of putting this 2 here if you're already putting a square root there. Are you getting it? But since there's a square root there, we just solve it the way it is. So normally, this will give us log. This square root here means 1 over 2. Are you getting it? So this is going to be 3, 5 to the power of 5, which is this power normally, times 1 over 2, all 27. All right? Which is going to give us log 3 to the power of 5 times 1 is 5 over 2, all what? 27. Now, 27 can also be written as 3 raised to the power of 3. Is that okay? So this will give us log 3. Now, everybody knows something. This 5 over 2, if it crosses to the back, it turns to 2 over 5. Is that okay? It turns to 2 over 5 according to the law of logarithm. That if you have log to base A of, let's say, C over D, if it crosses to the back, it's going to give us what? D over C log A. Is that okay? So this one, when it crosses to the back, the numerator becomes the denominator becomes numerator. And then 27 can also be written as 3 to the power of 3. Now, my dear student, this 3 to the power of 3, are you getting it? It can also cross to the back because this power here can cross to the back. If that power crosses to the back, you now have 2 over 5 times 3 and then log 3 over 3. This cancel will give us 1. Are you getting it? Because log 3 over 3, there's a lot of indices that say, logarithm that say log A over A is 1. Is that okay? So 3 over 3 is 1. So 3 times 2 will give us what, my dear student? 6 over 5. That is what is the numerator. So the correct answer here is 6 over 5. And that is that for this question.